Hi everyone, welcome to today's lesson on applications of graphing systems. When I say applications, I mean more real life examples of graphing systems. So we're going to work on, if I give you a graph or a situation, can you write the linear equation or the system of linear equations? And then also, can you comprehend some questions or follow-up questions? Can you understand them and answer them accordingly? Okay, so those are the two things that we're going to focus on today. All right, so first off, let's do a quick review. What is a linear equation? So equation means equals. When it's a linear one, so something that has an equals in it, linear equation means basically a line. A lot of times we like that line to be in the form of y equals mx plus b. Okay, what is a system? System of linear equations. System meaning more than one. So most of the time we will have two lines. Sometimes in higher level math classes you could have 3 or 4, but usually we just have 2. So what is a solution to the system? We are looking for a point. Remember, a point is the x comma y. And we are looking for a point that is on both lines. And how do we find that solution? We would graph both lines and find where they intersect. So where two lines intersect or cross. All right, so that was kind of our quick review of things that we have done in the past. We are going to now have a situation. Okay, so this deals with Cedar Point. And just so you know, I totally made up this, this scenario. Cedar Point is just a place that I like to go. So I made this about something that I enjoyed. So it says here, people are angry with Cedar Point. Many are complaining about the high admission prices. Some parents of teenagers claim that they have to pay huge amounts of money to enter this park and they don't ever ride any of the roller coasters. Cedar Point is worried that parents will stop coming to the park and then they will stop bringing their kids as well. So to please the angry parents, Cedar Point is deciding to change the admission based upon the number of roller coasters one rides. Okay, so we have two options. So I'm going to actually highlight those options. Option 1, I'm going to put in green here. So Cedar Point is deciding between these two options. Option 1, there is a $10 admission fee, and you must pay $10 every 2 rides. All right, the next one I'm going to put in pink here. Option 2, you must pay an admission fee of $40, and you must also pay $10 for every 5 rides that you go on. Okay, so we have two options here that we can choose from. We are going to, before we do anything, it says write an equation to represent how much money, y, each person will pay after x rides. So the first thing I'm going to do is I'm going to label my graph. It says money is y. So I'm going to put money or admission fees. And we're going to do that in dollars. And our x is rides. So I'm going to label my graph just to kind of help me visualize this a little bit better. All right, so now we're also going to be writing those two options as a linear function. So we want it to be y equals mx plus b. Some things to keep in mind is that b is always the starting point. So what is the starting amount to pay to get into the park? Our m, our slope, is always our rate of change. So usually you'll see the word per in there, something per or every. You're looking for those words for slope. Okay, so let's start with option 1. That was in green, so I'm going to write in green here. It says there's a $10 admission fee and you must pay $10 for every 2 rides. I'm going to identify my starting point first, my B. $10 admission fee, that is the start to get into the park. So that's going to be a plus 10 there. Now for my slope, again, that's the rate of change. It said you must pay $10 for every 2 rides. If I would turn that into a fraction, 10 for every 2 rides, that would be 10 over 2. And because it's a fraction, we know that we always simplify fractions. 10 over 2 is also 5. Okay, I'm going to do the same thing here, but this time for option 2. And put this in purple since I highlighted it in purple up there, or pinkish purple. Okay, so option 2, you must pay an admission fee of $40. That's the starting point. I'm going to put that for the B. And you must also pay $10 for every 5 rides. Make that a fraction. 10 for every 5. Simplify that. 10 divided by 5 is 2. So our rate of change, or our slope, is 2. Okay, now we're going to now transfer those over to our graph, and we're going to graph both of them. Start with the green one here. I'm going to start at $10. Now it's really hard to go up 5, right 1. So this is where I'm going to go back to the original problem. It said that they have to pay $10 for every 2 rides. So I'm going to go from $10, if I add $10, I'm going to go up 10, which would put me at 20, and over 2 rides. So my rise and run here is technically up 1 box over 2 boxes, but that is up $10 over 2. So I'm going to keep going that up 1, right 2, up 1, right 2. And because this is a system, I want to get as many points as I can, because I know I'm looking for eventually where the 2 lines cross. All right, now I'm going to do the purple one here. I'm going to start at 40. This had a slope of 2, but remember that was originally $10 for every 5 rides. So I'm going to go back to that. I'm going to go up $10, which would put me at 50 for every 5 rides. So I'm going to go all the way over to 5 rides. And I'm going to go up $10 for 5 more rides, which would put me at 10 rides now. And that is my second line. All right, so it says, after how many rides will a person pay the same amount of money for each option? So when are they the same? Well, that is when they intersect. How many rides is this going to be? That was exactly 10 rides. How much money will this be? Go over here to see your money. That would be $60. All right, last question. Which option is going to be the best if you only plan on riding 4 rides? Okay, option 1 here is in green, so if I find 4 rides, I'm going to go up. Option 1 costs $30. If I keep going up, option 2 is 40, almost $50, 40 something, maybe 48, I don't know, I'd have to plug it into my equation, but I know that that is going to be more than option 1. So my answer here would be option 1. Now, if you really wanted to know the exact amount of how much this is, you could always use your equation and plug in the 4 rides to get that answer. And 2 times 4 was equal to 8 plus 40. So when I estimated 48, that was exactly right. All right, so that was one example. I'm going to do one more example. This one's going to look a little different. So on this one, I gave you a situation and you wrote the equations from the situation. On the next one, I am going to give you a graph and we're going to write the equations from the graph. All right, so I'm just going to throw out names here. I'm going to use my brother and sister for their names. So my sister's name is Jessie. So anytime I see an A, I'm going to throw in her name here. I see Jessie down here. I'm going to use the color pink for her. And my brother's name is Jimmy. So I'm going to use blue here for him. All right, this problem is going to deal with getting money for allowance and how they're spending their money. Now, my brother and sister are 40 plus years old, so they're not still getting an allowance, but imagine that they're about your age. So it says Jesse and Jimmy have received allowances from their parents. Jesse likes to use her allowance to see movies at the theater. Jimmy likes to spend his money cheering on his school at the basketball games. Use the graph on the right to answer the following questions. It says to construct a function showing each person's amount of money left. Notice that's y, and our y is already labeled over here. After X amount of events. So notice that's also already labeled over here, number of events. Okay, so that's good that we already have our labels. We're going to use this equation, or use this graph to do the equations. So remember, Jesse was the movie. So I'm going to put Jesse over here, just so I can remind myself. I'm going to put Jimmy for the basketball. All right, so let's start with Jesse. So remember, again, we want y equals mx plus b. And b is our starting point. So how much money did Jesse start with? Well, if you look at the graph, she started with exactly $45. Now we have to find her rate of change, and for a lot of people, this is the toughest part. And so what I do is to find the change, I usually put in another point on the graph that's close. So now I have 2 points. Okay, so one thing that people like to do is to make a table with those 2 points. So our first point was the point 0.45, that was our starting point. The next point was 139. We can find the change between our x's, which was going up 1. Our y's were going down 6. And so our slope would be y over x, which is -6. Now, if you're looking at your graph, again, you can look at the graph. It went from 45 to 39. That was a change of 6. And when I went over, I went from 0 to 1 event. That was a change of 1. Again, we would do rise over run, which would also give you -6. So either way you do it, you should still end up with a slope of -6. All right, so now let's try Jimmy. Jimmy's starting point. How much money did he start with? Well, my parents must not have been as happy with what he was doing because they only gave him $30 to start with. And we need another point here, so I can use the point 127. So if I'm finding Jimmy's rate of change, I would do 0.30, and after 1 event, he had $27. So our change was, our x's were changing by 1. Our y's were going down 3. And if I made my fraction, remember y's go on top, so -3 over 1, which is equal to -3. Again, you could use your graph. We went from 30 to 27, so it went down 3, and we went from 0 to 1 event. And our slope would be rise over run. So either way you do this, Jimmy's slope is -3. All right, and just so you guys can kind of get what exactly this means, this was how much money my parents gave them to start with, and this was how much they were paying per event. So when it said 6, Jessie was paying about $6 to go to the movies. So every movie she was paying $6. Whereas Jimmy was going to basketball games, the school basketball game, and it didn't cost as much. It was $3 per game. And so that's kind of what the slope and the y-intercepts mean in this problem. Okay, now it says to consider the point where the lines intersect. Well, they intersect right here. It says explain what the point of intersection represents in terms of their money situation. Be sure to include the coordinates. That's a big key. We need this. Include the coordinates of the point in your answer. Okay, so off to the side, I'm going to first label that point. Remember, it's an x, comma, y. My x is 5. My y is 15. Now I'm going to put labels to those numbers. That was 5 events. And 15 money remaining. So I know it's money left. And once you have that part, that's the hardest part, we just have to make it match and kind of explain it in words. Don't just say 5 events, 15 money left. that sounds a little strange. We want to turn this into a sentence. So we could say after 5 events, they both had $15 left. You could even say of their allowance. But I am definitely looking for 5 events and $15 left, and something about them being the same. That is when they have the same amount of events and the same amount of money remaining. Okay, so we had Jimmy here and my sister Jessie. Fill in those really quickly. All right, so how many basketball games can Jimmy attend? So let's look at our basketball games. He started with $30. When did he run out of money? That was at 10 games. All right, let's go to Jessie. How many movies can she watch? So she started off with $45, and when did she run out of money? I don't know, that's like 7 1/3 or 7 1/2. But we can't go to half of a movie, so she would have to stop at 7 movies. She can't go to 8. They won't let you pay for half a movie. So she went to 7 movies. It says, how much money does Jessie have left over when she goes to those 7 movies? Well, let's go over to our money. She would have had $3 left. And that is it for our notes for today. You guys do have homework, and there's also an answer key posted. Let me know if you have any questions. All right, see everyone soon. Bye.